Alright, physics teachers, check this out. I want to present to you a new method, perhaps, of solving conservation of momentum problems. I want to see what you think about it because I think it's better for much of what we want to do. We want these kids to understand that physics, we don't necessarily have to have them understand all the algebra. So let me show you what I got. You got the 10 kilo, this is a conservation of momentum problem. 10 kilogram meters per second at kilograms at 20 meters per second. 5 kilograms at 15 meters per second going in the opposite directions. Two objects, they stick together, they travel off. What's their final velocity, speed, and direction? Total mass is 15 kilograms because you took the 10 plus the 5, you got 15. So what I'm going to do is just do this with vectors. We like vectors, we think we really like vectors, but I don't think we use them enough. So here's 10 kilograms at 20 meters per second. P equals mv, and that's 200 kilogram meters per second in that direction. And then we have this one, 15 times 5. You have 15 times 5, 75. Now, make that thing a bit shorter because it is significantly shorter because 75 is much less than 200. Put it in the opposite direction, so you have those two. This is 75 kilogram meters per second, P equals mv. So, I've got those two. This is the initial momentum. And I know that the initial momentum, however you want to write it, the total of the initial momentum of this thing on this side over here is equal to the total of the final momentum on that side over there. So here's the one situation, then you got the after. So you take those two, you look at them, and really all you have to do is look at it. It's not this complicated algebra problem where you take this times this plus this times negative that equals this times that. No, none of that stuff. You just look at this thing, you're like, oh, they're opposite directions, so you take one, you subtract it, you get 125. This is 100, momentum is 125 kilogram meters per second in that direction. It's nice and big. And then I know that P equals mv, this is 125 kilogram meters per second is equal to 15 kilograms for the final object multiplied by its velocity. And you get something or other. So you get the answer, and that is it's 115, 30 to 8.33 meters per second, and it's in that direction. So we have them thinking about directions and actually drawing the directions. Really simple math. P equals mv, or v equals p over m. That's it. So arrow, arrow, look at it, think about it, arrow, and then divide, and you're done. So that's one solution. Here's a different one. I should have left that one there. This is 5 kilograms at 15 meters per second. Then you have the two bounce off each other, making up numbers, whatever they happen to be, because in general, unless you have an honors class that you really want to derive the elastic collision equations, you just have these things like bouncing off each other and doing different things. Still one-dimensional problems. And that thing is going to be going at 5 meters per second in that direction. And so the question is, it's 10 kilograms. And the question is, what's the speed? Oh, maybe it's in that direction, maybe, I don't know, but this is it's 5 kilograms. So then I can actually just leave this out entirely. And what's the velocity of that thing right there? So you set it up exactly the same way. You have 200 kilogram meters per second because P equals mv. And then here, 15 times 5 is 75, so you have a shorter arrow in the opposite direction. P equals mv, 75 kilogram meters per second. That represents the before, and I know that that's 125 in that direction. And then afterward, just write down what you have. That is right there. That's 50. So I have 50 kilogram meters per second in that direction. 50 kilogram meters per second. And this plus whatever else is here has to add up to these two right here. So the total is 125. P total equals 125 kilogram meters per second in that direction. So I can just look at that and say, okay, what do I have to get? Get 125 in this direction, so it looks like 175. And of course, it's going to take the students a little bit longer to do that, but This is 175 in that direction. Minus 50 gives you, okay, so they both turn out to be the same. And then that 175 kilogram meters per second equals 5 kilograms. 5 kilograms times V. And 175 divided by 5 gives you 35. V equals 35 meters per second toward the bottom of the page, toward the bottom of the board, down, south, whatever it happens to be. And there is your answer right there. So from what we have been doing and from what every book does and all the YouTube videos, every one of them uses algebra. And as you get more and more objects, you get more and more complicated. Sometimes we have to give them m1v1 plus m2v2 equals m1v1 prime plus m2v2 prime and all that junk. And then they have to fill the thing out. We'll just do it this way. Why can't we just use the concepts of vectors and use these vectors appropriately so that we get a nice, simple-looking problem and they can solve it? And this might actually allow our students, the lower-level students in conceptual class, regular class, to be able to solve these. Now, I solve these, the two-dimensional problems, where you have one going this way, one going that way, or one comes in, hits another one, other one goes off this way, one goes off that way. I also solve these in a couple of different videos. They'll be linked down below in the description. But this is a method that we can use for all the conservation of momentum problems that we have. So what do you think? Get back to me. Think about it for a while. And if you actually test it, please tell me your results in comparison. Thanks.